Have you ever looked up at a plane and wondered how something so heavy can stay aloft? It seems almost magical, defying gravity with ease. But there's no magic involved, only science. Airplanes fly because of a delicate balance between four natural forces: lift, thrust, drag, and weight. Understanding these forces unlocks the secrets of flight. It reveals how engineering ingenuity works in harmony with the laws of physics. Imagine a bird soaring through the air. It seems effortless, but the bird is constantly managing these four forces. Lift is the force that pushes the bird upwards, counteracting gravity. Thrust is the force pushing the bird forward, generated by its flapping wings. Drag is the air resistance that slows the bird down, and weight is the force pulling the bird downwards due to gravity. For a plane to fly, these forces must be perfectly balanced. Lift is the force that makes a plane rise into the air. It's generated by the wings. But how? The shape of an airplane wing is crucial. It's curved on the upper surface and flatter underneath. This shape is called an airfoil. When air flows over the curved upper surface of the wing, it has to travel a longer distance. This faster-moving air creates an area of low pressure above the wing. Meanwhile, the air flowing underneath encounters a shorter, flatter surface. This slower-moving air creates an area of high pressure below the wing. The difference in pressure between the top and bottom of the wing creates lift, pushing the plane upwards. This is known as Bernoulli's principle. Thrust is the force that propels the plane forward. Think of a swimmer pushing off the pool wall. That initial push is like thrust. In aeroplanes, thrust is usually generated by engines. There are two main types: jet engines and propeller engines. Jet engines work by sucking in air and mixing it with fuel. The mixture burns and expands rapidly, creating a powerful jet of hot gas. This jet is forced out of the back of the engine, propelling the plane forward. This is a demonstration of Newton's third law of motion. For every action, there is an equal and opposite reaction. Propeller engines work a bit differently. They have large spinning blades at the front. These blades are angled to cut through the air like a screw, pulling the plane forward. Whether it's a jet engine or a propeller engine, the principle is the same. Create a force pushing the plane forward. Drag, the unseen force. Drag is like an invisible hand trying to slow the plane down. It's the resistance the plane encounters as it moves through the air. The faster the plane goes, the stronger the drag. Several factors contribute to drag, including the shape of the plane and the smoothness of its surface. Think about putting your hand out of a car window. A flat hand encounters more resistance than a hand held vertically, slicing through the air. Engineers have developed sleek aerodynamic designs to reduce drag. They use smooth surfaces, streamlined shapes, and special materials to minimize air resistance. This allows planes to fly faster and use less fuel. Weight, the force of gravity. Weight is the force pulling the plane down towards the Earth due to gravity. It's a constant force that needs to be overcome for a plane to fly. The heavier the plane, the more lift it needs to counteract its weight and stay airborne. This is why cargo planes are much larger than passenger planes. They need to generate more lift to carry heavier loads. During flight, the weight of a plane can change. As fuel is consumed, the plane becomes lighter, requiring less lift to stay aloft. This is why pilots constantly monitor and adjust the plane's controls to maintain the delicate balance of forces. Takeoff, reaching for the skies. Takeoff is the most exciting part of the flight. It's where the four forces of flight come together dramatically. To take off, the plane needs to generate enough lift to overcome its weight. The engines roar to life, providing the necessary thrust. As the plane accelerates down the runway, the airspeed over the wings increases, generating more and more lift. Eventually, the lift force becomes greater than the weight, and the plane gracefully lifts off the ground, climbing into the sky. Steering the skis ailerons, rudders and elevators. Once in the air, pilots maneuver the plane using control surfaces on the wings and tail. These surfaces work by changing the airflow over them, generating forces that turn the plane about its three axes: roll, pitch and yaw. Ailerons are located on the trailing edge of the wings. Moving them in opposite directions causes the plane to roll. The rudder is on the vertical stabilizer, the fin, and controls yaw, which is the plane's left or right movement along its vertical axis. The elevators are on the horizontal stabilizer, the tail plane, and control the pitch, which is the up or down movement of the plane's nose. By carefully adjusting these control surfaces, pilots can steer the plane, ascend or descend, and even perform complex maneuvers. It's like riding a bicycle in the sky. Landing a controlled descent. Landing is essentially a controlled fall from the sky. The pilot reduces the engine power, decreasing thrust. This slows the plane down and reduces lift. Simultaneously, the pilot adjusts the plane's attitude to initiate a descent. Flaps are extended on the wings to increase lift at lower speeds, allowing for a controlled landing. As the plane gets closer to the ground, the pilot further reduces the engine power and gently guides the plane onto the runway using the ailerons and rudder to maintain alignment. The plane touches down, the wheels spin, and friction helps to slow the plane to a stop. The final approach. As the aircraft nears the runway, the pilot must carefully execute the final approach. This phase is crucial, requiring precise adjustments and sharp focus. The plane aligns with the runway, gliding smoothly at a steady descent rate. Pilots rely on a mix of instruments and visual cues to ensure the aircraft is perfectly positioned. The landing gear is deployed and the plane begins its gentle glide down. During this critical phase, the pilot continually adjusts the throttle, flaps, and control surfaces to maintain the optimal descent path. Everything must be in harmony to ensure a safe and smooth landing. Conclusion: a symphony of forces. The next time you see a plane soaring overhead, remember the intricate dance of forces at play. From the lift generated by the wings to the thrust of the engines, from the drag slowing it down to the weight pulling it down, every flight is a testament to the balance and harmony of these forces. It's a marvel of engineering and a beautiful demonstration of the laws of physics. So next time you're up in the air, take a moment to appreciate the science that makes it all possible. It truly is a magical experience. In our exploration of flight, we've uncovered the fascinating science and engineering that make it all possible. But our journey doesn't end here. There's so much more to discover about the wonders of the world and the marvels of human ingenuity. If you've enjoyed this deep dive into the forces that keep planes in the sky, make sure to like this video and subscribe to our channel. By doing so, you'll stay updated on all our latest content, and together we can continue to explore the incredible phenomena that shape our world. Hit the notification bell so you never miss an episode, and share this video with anyone who has ever looked up at the sky in wonder. Your support means the world to us and helps us bring you more exciting and educational content. Thank you for joining us on this journey. Until next time, keep looking up and stay curious.